Good morning, everybody, and welcome to this UKSTT mini masterclass on the subject of pipe ramming. My name is Tom Sangster. I'm the chairman of the UKSTT's Technical and Education Committee. It's my pleasure to be your host for this event this morning. Our speaker on pipe ramming will be Roger Vaal. Roger is Managing Director of Tracto Technik UK Limited. He will speak on pipe ramming, and you will be joined afterwards by two colleagues, Roger Atherton and Björn Feimelt, who will answer questions alongside him. Roger, if you could move the slide on, please. Just a little bit of housekeeping. At the top right of your screen, you should see a little taskbar, and there will be a little symbol with a question mark. Click on there, and you can write a question, which will come to us, and we will see, and we'll do all the questions at the end of the Roger's presentation. You can ask a question at any time. They get stacked up, and then I'll read them out. We are recording this, and it will be available on the YouTube channel afterwards. UKSTT has a lot of technical resources available through our website. You see the address on the screen now. A lot of technical information about trenches techniques, technical inquiries. If you have a particular technical problem that you think may be solved by trenches technology, we're happy to answer those. And also on the website, you can find information about the events. We have a lot of online events like this, and also from September, we'll be restarting live events with No Dig Live from the 14th to 16th of September. So without further ado, I'll pass you over to Roger Vaal to tell us all about pipe ramming. Roger.
Yes, Tom, thank you very much for your introduction, and thank you to all the attendees for taking the time to join this webinar. Subject matter today is pipe ramming, and I'll be taking you through a more detailed overview of the technology. Then we're going to look at some practical applications, and I will summarize with the key advantages and benefits of the process before we go into the questions and answer session. So, what is pipe ramming? Pipe ramming is a trenchless method for installation of steel pipes and casings. Typically, we see distances of up to 30 meters and diameters of 1.5 meters, but the method can also be used for much longer and longer distances and larger diameters. The method is useful for pipe and casing installation, for example, under railway lines, under roads, where other trenchless methods could cause subsidence or heaving. The majority of installations are horizontal, although the method can be used in any direction, really. Very often when talking about pipe ramming, people say to us, oh yeah, pipe jacking. And there is some major differences between pipe ramming and pipe jacking. The biggest one is that ramming uses percussive energy, and the machine is freestanding, whilst with pipe jacking, it uses hydraulic jacks and needs some extensive shoring. Pipe ramming is preferable for shorter distances and applications that do not require tight directional control, such as, for example, cable installations. The pipe is generally open for the installation, and the front soil cutting shoe reinforces the front edge of the pipe and directs the soil into the pipe during the ramming process. And then spoil removal from the pipe is usually carried out after the entire steel pipe has been installed and is in place, and it is generally achieved by either augering compressed air and water or with bigger pipe diameters, with conventional earth-moving machinery such as mini diggers or skid steer loaders. So, pipe ramming technology is often applied where it's essential to to avoid any subsidence, and also where it is essential that we don't have extensive vibration in the surrounding area. So we can ram pipes, for example, under existing railway lines, under roads, but also under buildings. The typical setup of a ramming site starts here with the front at the product pipe. We have got the described cutting shoe, then the product pipe. The product pipe is then connected to the ramming to the rammer, first with a set of what we call cotter segments. The cotter segments sit on the face of the product pipe and act as an adapter between the pipe and the ramming cones. The ramming cones are really the adapter between the rammer and the pipe itself, but they also act as an opening for soil removal. You then have tensioning straps that make sure that the rammer is absolutely firmly and tightly fixed into position, and the tensioning straps fix A to the product pipe, but B also to a so-called pushing plate, which is installed at the rear end of the rammer itself. It is generally good practice to then support the rammer for best line and level performance, and we generally recommend the use of cradles, which are then sitting on some kind of guidance rail. So let's take a closer look at what a rammer looks like. And if you are familiar with the inner workings of a soil displacement hammer, of a mole, then you'll find that the rammer is much the same, really. It is pneumatically operated, has got a piston, and the piston hits the front end of the housing. Now, there is various rammers out there, and one of the main unique product attributes of our rammer, the Groundwater ram, is the fact that it comes in what we call a mono body. So there is no segments in there that are, for example, screwed together. Therefore, there can't be any components that loosen during operation. The machine becomes very, very reliable and has very, very low maintenance requirements. But more about the machines in a minute. Let's have a look at the process itself. Now, one of the first major advantages of the ramming process is the way that it transmits the forces during operation. The piston and the front end chisel obviously slam into the front end of the rammer housing, generating forces that are transmitted through the conical front of the machine into the ram cone, and then along the cutter segments. And these are really responsible for making sure that this energy that is generated is transmitted in a linear fashion into the product pipe. So all the force, once it enters the product pipe, the vast majority of the force, I should say, is transmitted in a linear fashion through the pipe. There is virtually no vibration transmitted laterally into the surrounding area. That we wouldn't call it vibration, we would call it more resonance. Let's call it resonance, for lack of a better word. And this makes it so unique because it allows for very shallow installations and also installations close to other utilities in the ground. So one of the reasons for that to be possible is the fact that the power is transmitted only through the product pipe linearly. The other is that the majority of the spoil is actually left within the product pipe that we install during the installation process. This is what we see here on these pictures. This is the installation of a rammer in preparation of the ramming process. As you can see, there's very little infrastructure that is required around it. It makes it that the rammers are generally very, very simple and straightforward to set up because they are, as we say, freestanding, and because they generate their own percussive forces. There is no need for big abutments or thrust walls. No extensive civil engineering that needs to be around it, other than the excavation of the starting and the receiving pit, and maybe the installation of any guiding rails that you can see on this first picture here. So one of the advantages is a quick setup and also a quick demobilization after the job has been completed. There's a good number of considerations when you start planning for a ramming job. First and most important, two considerations to remember is it is a technique that even though the soil displacement is minimal, it still requires soil displacement. Therefore, we cannot ram through solid rock. And secondly, the only pipe material that can be rammed is steel pipe. There's a large number of other considerations to take into account. The soil type that you have, density, sorry, whether there's any cobbles and boulders, their size, their percentages, the pipe size that you want to install. That is some of the equipment considerations, but we have time considerations as well. As we generally install steel pipes in sections, there is time considerations because we may be required to weld different steel sections together. So that is a time-consuming process. We have to consider the length that we want to drive. There is a limit to the distance ramming can go. It obviously depends on the size of the machine, the size of the pipe, and the soil type. Spoil removal needs to be planned carefully, and especially on longer pipe rams, we want to make a decision on whether lubrication of the pipe during the ramming process is is required or not. And also we need to plan for potential downtime, though it has to be said that ramming is one of the few trenchless installation processes where even extended downtime may not necessarily lead to any problems. This is just quickly showing you the extent of different rammers that we offer as Tracto. We offer rammers from 95 millimeters in diameter that weigh 59 kilograms to our biggest rammer, which is 800 millimeters in diameter and weighs 11.5 tons. And they range in impact energy from 230 Newton meters to 40,500 Newton meters. All of this information is available online, but I just want to point out these three small, short Groundwater machines, the Mini Atlas, Mini Olymp, Mini Gigant. These are specific solutions for ramming in very, very confined spaces. They may not give you the same ramming force, but they may be the solution if you really have very, very tight conditions on site. Selecting the right size rammer for the job is absolutely essential. As we said, it depends on the length and the diameter of the pipe that you want to install, but also on the soil conditions. This diagram that I'm showing you here only shows the installation length on the x-axis and the diameter, the outer diameter of the product pipe on the y-axis here. So you see that we can ram from 50 millimeter pipes all the way up to 4,000 millimeters. So 4 meter diameter, and many rammers can do a broad range of different diameters. Take, for example, the Colossus, which can ram from 500 millimeter all the way to 1.2 meter pipes. And the selection depends very much on the ground condition. And in reality, sometimes you look to choose the right rammer for the job, and you end up being on a borderline. My suggestion would be, if you are unsure or you know that you've got tougher ground conditions, always go for the bigger rammer. If in doubt, go a little larger. When ramming, it is key to really prepare the site properly and make sure that you put everything in place to get the end result that you want. And if you are relying on directional accuracy, we always recommend to install some type of a rail system to be able to use a cradle to achieve best line and level. Do remember, this is a non-steer application. The length and the diameter of the pipe will dictate the size of the starting pit. You've got to make sure that there is enough space around the rammer, and it is advisable to leave quite a bit of space behind it. Also, what is very, very important to remember, if you are installing segments of steel pipe, you want to make sure that you allow for these to be welded together, but welded together on site. So you want to leave what we call weld sumps to enable you to weld all the way around the pipe. When it comes to steel pipe selection, we can use virtually any steel pipe that is available in the market, whether they're longitudinally welded, spiral welded, whether they're seamless, whether they have insulation protection. But what is important is that we have to ensure that the wall thickness, there's a minimal wall thickness that we recommend. Remember, there's in essence brute forces going through these pipes, and if the wall thickness is too thin, we may end up destroying, buckling the pipe or flaring the pipe. So wall thickness is important. And just to give you an example on how to read this this chart, take, for example, a 500mm pipe that we would want to, or 20-inch pipe that we would want to install over a 25-meter distance. We would always recommend a minimum of 10mm wall thickness. So the inner diameter of your product pipe cannot be more than 480mm maximum. It is good practice to have the minimal amount of connections to be done on time, but that obviously depends very much on the space that you have to your disposal. What is absolutely critical is the quality of the butt welding. It needs to be a full penetration butt welding to ensure a successful ram. This can be very time consuming. So again, maximize the pipe length if possible. If you have got enough space, maybe even pre-weld several sections of pipe together before getting onto site. If you have got the space, maybe even weld the entire pipe length before starting the installation. And when it comes to starting the installation, it is crucial to think about the front of the pipe, the leading edge, the cutting shoe, whatever we want to call it. It is in most cases it is necessary to reinforce the front of the pipe. Depending on the ground conditions, that can be achieved very simply, often by just cutting a section of the front of the pipe off, opening it out, putting it around the pipe and welding it onto the pipe, and then creating this little chamfer angle here to have a lead-in for the soil into the pipe. That can be done for giving ground conditions. In reality, it will always depend on the conditions that you face. So experienced contractors have got their preferred method of creating a leading edge or a cutting shoe. If you are in difficult ground conditions, you can do things like here, top middle picture, where they are welding little little carbide teeth in between the reinforcement sections. We've heard of people welding on bucket teeth, excavator bucket teeth. Your creativity knows no bounds here, and it is very much to the liking and in line with the experience of the contractor what is being done here. When you are thinking about longer distances, you may want to consider reducing the skin friction of the pipe during the ramming process, and that is where Bentonite Assist comes in. So Bentonite is not only lends itself to HDD drilling, but also to the ramming process. However, you've got to consider on how to get the bentonite to the front of your cutting shoe, and it is very easily achieved by simply tack welding sacrificial bentonite pipes, steel pipes, to the outside of the product pipe. And this is what then becomes the outcome. This is what it looks like in practice. A little bit messy, but it works. It will be helpful to reduce skin frictions over the longer distances at a pipe ram. The last main consideration is then on how to remove the spoil when the pipe has been successfully installed. And there's various different methods with compressed air, with high pressure water jetting, or you may want to auger the spoil out. And in the bigger pipes, as we said earlier, we may look at using skid steer loaders or even mini excavators to clean the pipe after the installation. A question that is sometimes asked is, how about big boulders? How do you get big boulders out? And what if a boulder gets stuck in the pipe? Well, whilst that is theoretically possible, it is very, very, very rare that a boulder gets stuck. Remember, the cutting shoe serves as not only a lead-in for the spoil, but it also helps to break up the boulder. So generally it doesn't get stuck. In the rare occasions where it does, you would be able to pinpoint reasonably well where that happened, and you may even have to abort the pipe ram, because all of a sudden obviously the spoil cannot be let into the product pipe anymore, and you might end up well, in simplistic terms, converting your pipe ram into a soil displacement hammer, and all the soil will have to be displaced around the outside of the pipe, which may lead to heave that you are trying to avoid. So that could be the most severe outcome, but often you can just simply carry on. The machine may have enough power to simply carry on with a boulder stuck, and you just push it out the other end, and maybe add a few segments to be able to get it out the other end, and then just cut off the pipe there. I hope that explanation makes sense. Anyway, you would know if something got stuck because your speed of progress would suddenly drop. But as I said, this is a very, very rare occasion. And really, that is the process explained from start to finish. So let's see how we can translate the theory into a little bit of practice and have a look at what's been happening in the real world. And the first example I would like to show you is a pipe run that was completed near Prague in the Czech Republic, where a 1.8 meter pipe was installed at a depth of 4 meters under a motorway, at a length of 46 meters. And in this first picture here, you see the starting pit that was excavated. You can make out that this is very, very hard and compacted clay. The contractor has gone to a lot of trouble to properly prepare the site. They have even put a concrete foundation in place for these I-beam rails to be installed to hold the cradle. They had a, I think it was a 12-meter section of steel pipe prepared for the ram. You can see here the rammer being prepared to be installed. There's actually 3 large compressors on site. You see here the 3 air hoses. So ramming requires large volumes of air. And also here on site, I don't know whether you can see my cursor, is the ram cones and all the various pieces of equipment. In the right-hand side picture, we see the cotter segments in place and the ram cone actually installed. The red ring here on the end of the rammer is the pushing plate, and they used a combination of steel chains and straps to firmly put the rammer, hold the rammer in place. And also good practice is to mark the pipe with the distances that you're doing. That helps you to gauge the speed of progression during the operation. And what we can also see here is the tag welded lubrication lines. So they obviously used Bentonite Assist on this ram. Again, exemplary, and that's why we're showing it, are these welding sumps. Because as you can see here on the right-hand side, the first pipe that was laid out was actually to 24 meters. And if we carry on now, we can see that in the end, they welded more pipe to it to get to the 46 meters that they required. And this picture here shows the reinstallation of the rammer after the second segment was actually welded on. So what you also require on site for this side rammer is a good crane. But from this picture, you can see they dug an extremely small receiving pit, and because they've gone to the length that they had in the preparation, the pipe actually came out exactly where they wanted it to come out, and the ram was completed successfully. Another example that I would like to share with you is this one. You may have seen this picture before. We like to show this at exhibitions. This was a job site in the north of Germany where we installed 44 pipes of 120 millimeters, 1.2 meters in diameter, in a circle to create an underpath under a high-speed rail line. And all of this was done with the rail operations still intact, in place, without having to shut down the rail line. And here again, preparation was absolutely essential, and it was key that the pipes were all absolutely parallel. And what we did here was we prepared the pipe to have them linked together, and that was achieved very simply by welding onto the one product pipe a simple T section and 2 L sections onto the other product pipe, so that there was guidance beyond the line and level. That was obviously carefully considered as well. And this was the site after the ramming had been completed, and then obviously all they had to do then was to finish the civil engineering work, take out the spoil inside, and this is what the finished product looked like. So, as I said, ramming lends itself to all sorts of installations. As long as we install a steel pipe, we can install it, well, almost anywhere, whether it's culverts under roads, under rail dams, whether it's an underpath, a road, or a cycling path, or whatever you want to install. The picture on the far right shows again the installation of a steel pipe at very shallow depth during whilst keeping the flow of traffic, rail traffic, uninterrupted. So it is highly flexible. Ramming also doesn't need to be horizontal. We can ram in almost any direction. So vertical installations are possible as well. For example, here, foundations, support columns for all sorts. Smaller pipes have been used to as support for and foundations for solar panels. So ramming is possible uphill, downhill. We can pull in, we can pull out, as long as it's steel and as long as it's not rock. So that's the general principle. I wanted to introduce you to some of the lesser known applications of ramming, applications that we often group under the general term of HDD assist. So I would like to take a quick look at pullback assist, the installation of conductor barrels. They're often called steel casings or lead-in pipes, and the drill rod rescue process. So let's start with the pullback assist on larger installations and longer pulls. A drilling contractor may decide to help with the installation during the back reaming process by attaching a hammer onto the back of the installed steel pipe and then letting it assist during the pipe pulling process. I've got some pictures here for you showing this in action. That was taken in the States. So they have had the product pipe laid out, even went to the trouble of having cable cranes to guide the product pipe, and at the end of the pipe we installed the cotter segments and the rammer, so to ensure and guarantee a safe and successful installation. Lead pipes are often used for HDD processes where at the beginning of the drilling process the soil conditions are not ideal for HDD. We have had a couple of applications here in the UK where ducting was installed to connect offshore wind farms to well, onshore, and the HDD operation started in the well in the beach area and sand is notoriously difficult to drill, as we know. So these conductor barrels are installed, and until we hit more drillable soil conditions, and it makes for easy lead-in, either for your standard drill head or for down the hole hammers or mud motors. And remember, we can ram these casings in, but it's just as easy to get them out again. All you need to do is flip around the rammer. It's a little bit more complex than that, but yes, deinstallation of the lead-in pipes of the conductor barrels is also possible with the ramming process. And last but not least, drill pipe rescue. So here, if on a larger HDD project a drill pipe gets stuck, or well, generally a reamer gets stuck for whatever reason, we can use ramming to try and free this rammer, or we can use the rammer to help pull sorry, lost my thread here, to help push the reamer through the soil conditions. And we've ourselves have been involved in a rescue operation in Saudi Arabia, where a 3-kilometer 30-inch pipeline was installed under the seabed, and at about 2.7 kilometers in, one of the power packs to the HDD drill rig developed a problem, and for a multitude of reasons that we don't really need to get into in this presentation, the reamer stayed where it was, 300 meters away from it was a pre-ream. Thankfully, they weren't pulling in the product pipe at this point, but the reamer stayed around about 300 meters away from the receiving side, and yeah, got stuck there for 6 weeks. So we were called out to try and get this reamer going again, and this picture here on the left shows the HDD pipes being disconnected to allow for a specialist ramming adapter to be put onto the existing drill pipe. And yeah, the work began. Here you see the rammer being installed, being shored properly, and being strapped, just like following the process as if we would attach it to a normal product pipe. And it actually took a full 10 days to get the reamer going again, but it did move, and the contractor was able to complete the pre-ream, and then also complete the final ream. And this 3-kilometer steel pipe was in the end installed successfully, saving the contractor a lot of time, a lot of money, and certainly faith. So that is ramming. I hope you agree that it's a very, very versatile, simple but versatile process. And I would just like to take a couple of minutes to summarize the main advantages of ramming. Ramming is possible at very, very shallow depth. There is minimal ground disturbance. There is virtually no risk of heave or slump. There's minimal settlement. It is suitable for most soil conditions, including soils with unstable cobbles and boulders. Again, no rock, no solid rock. It can be used in almost any direction, upwards, downwards, vertical, horizontal. There's minimal ancillary support required. We don't need to have extensive thrust blocks put in, extensive shoring. One rammer can be utilized for a wide range of pipe diameters. There is, as we've seen, multiple applications, and with it being freestanding, there is very, very short setup times, but also very, very short demobilization times. But we've got to be fair and open. There is some advantages, disadvantages to pipe ramming. It is very, very noisy. So especially in inner city or urban areas, it might not be socially acceptable. And it is a non-steer pipe installation process. So whilst it is very, very accurate, we generally see no more than 1% of deviation, provided that you've leveled it correctly. It remains non-steer. So what if you have a project and you're unsure whether that is a potential solution for you? Well, we invite you to give us a call. My colleague Roger Atherton, who's on this webinar with us, has got years and years and years of experience in pipe ramming applications here in the UK and further afield. In fact, the job in Saudi Arabia that I just showed you was undertaken by Roger himself. So ask us, and if we don't have the answer for you, we have a team of specialists at our main factory in Germany, and again, one of our product specialists, Björn Freimut, is also on this webinar today, and both Roger and Björn are happy to answer any questions after this presentation. We do have a multitude of different support materials, videos, animations. Our brochure is fairly informative. There is proposals on how to structure tender documentation and so on. So please, if you have any information requirements on pipe ramming, make us your first port of call. We'll be happy to answer any questions. And that brings me to the end of my presentation. I hope you found this interesting, and I would like to now say thank you for your interest in the subject matter, and invite you to ask any questions.
Thank you, Roger. Certainly a very interesting presentation and a great overview, not only of the technology, but also some of its applications. And I'm sure you know that the pipe-proof support project that you show, that application is always a very impressive one for this technology. We're joined now by Roger Atherton, Roger's colleague here in the UK, and hopefully also by Björn Freimut from Germany, who joined just despite today being a public holiday in Germany. And we have a few questions. I have prepared a few, but then you went and answered them as you went along. So I've kind of run out a bit now, but I still have a couple up my sleeve. Firstly, I would say pipe ramming is possibly an underused technique in the UK. We know it's used widely in the US, and you've given us examples in continental Europe as well. So it's very good to see an expose of it like that, and I think it gives us all plenty of ideas as to what we may be able to do with the technique. So some questions. The first one comes from Peter Taylor. And the question is, why don't you manufacture the larger ramming machines with a reverse for easy disconnection from the pipe prior to welding on subsequent lengths?
Microphone, Roger.
Yeah, hi everyone. Thanks for the question, Peter. We've been asked that many times in the past, and I do believe if a customer has a project and he's looking to potentially purchase a machine from us, we can, I believe, but I would need to double check, I believe we can manufacture and supply what we call a reversible machine, where when the installation is complete or each pipe length's been installed, we can actually switch the machine to reverse, so the piston's striking more at the back to relieve the or crack the machine from the pipe. You're quite right, Peter, in asking that sometimes our customers do have problems disconnected from the pipe after each length's been rammed because the impact energy has driven the rammer so tight in the pipe it's difficult to break it, ready to lower the next steel pipe for welding. But this is not a common problem, I wouldn't have thought. I mean, we do use the aid of lifting facilities on site to lift the machine whilst it's not working and the compressor's turned off, to try and break that seal between the rammer and the pipe. But I do accept that sometimes it can be difficult to break the machine, but it hasn't caused us enormous problems over the years in the past. But Peter, I could certainly check to see whether we're still able to supply a machine with a reversible system to it. But yeah, thanks for the question, Peter.
Thank you, Roger. Peter's also got a second question. Pick it up on my screen with the size I can read. Do you have any data on noise levels for different machines? I know, Roger, you did mention it's noisy towards the end. Any particular data to quantify that, decibels?
Yeah, we do have noise decibel readings for various diameter Grunda rammers, but essentially that can differ because obviously each job site will have an effect and have different sound readings. So it's really, I would say, down to the contractor and the design engineer on the project to look at where he's ramming and the location and the kind of topology he's working in and the kind of environment he's working around, to see and find out what the decibel ratings would be and the restrictions are on him. But yes, we can certainly give you noise readings for each machine as a general rule of thumb at a given distance. So if anybody wants that information, I'm happy to, and as an individual within Tracto UK, give that information out afterwards. Not a problem.
Okay, good. So that's data that is available if it's an issue for anybody. Thank you.
Of course.
Move on to one from myself. It appears that what you're ramming in is always or almost always steel casing, and then something else will be inside it. Is that correct, or can you directly ram a product pipe?
Yeah, I mean, as Roger alluded to during his good presentation, we can only ram steel casings. And for example, if we're ramming in if someone wants to install a large sewer pipe and they feel ramming is a solution, then we would always suggest perhaps a larger steel pipe is installed, which will then give the contractor to install a smaller sewer pipe, but allow him to give them that finer gradient at the end of the installation, where perhaps the tolerances have not been achieved with the first steel pipe installation. So yes, we have done that in the past on several projects, but effectively it's always a steel casing. But I have to say, and I would stress on what Roger mentioned earlier in his presentation, that in all my years of experience in ramming, we've always worked together with our customers, and we've always made a fairly high tolerance target achieved. I mean, I always guarantee, really, you know, within 1% over the distance. I mean, in most cases, it always comes much closer than that. And we can ram, you know, within inches of our target, of our targets. It's always about good setup, a good base support for setting up your grunder ram. Get your first pipe in really accurately, quite slowly, take your time. And once your first, for example, 12-meter length of steel casing is in position, and providing you will on your subsequent pipes very accurately, with great, you know, with great care to get them in line, pipe ramming can be accurate. I mean, you know, people have this misconception it's not a non-steered, but you take your time to set up your grunder ram and the support system, a support foundation. Ramming can be accurate.
If there's any specific material specified that the contractor wants to have in, yeah, as part of the installation, I mean, it can be inserted into the steel sleeve. For example, if you are required to have a PE pipe, you know, with some swage lining or just a simple sort of pipe insertion methods, you can install that in the sleeve that you had previously rammed in, and well, you can, for example, use a burster for that, as we mentioned in the previous webinar. So
maybe I didn't phrase the question very well. Sure, and we understand you're ramming a casing, you can put whatever you like through it afterwards. And then what you're ramming is always steel.
It is always steel.
Perhaps there's more around if you're installing, say, a steel gas pipe, could you directly use the casing that you've installed as the pipe and just connect to the ends of it with steel pipe? Or is it always the case that something else is inside? The question wasn't around accuracy, that's accepted.
Okay.
But, you know, and that it's always steel, that's accepted. But can the casing that you ram, the steel that you ram, ever be used as a product pipe? Or is
yes. Apologies, Tom. Yeah, Bjorn, sorry, do you want to answer that as well?
Sure. Yes, that is possible as long as the pipe is for the trenchless and sandbed-free installation, according to the requirements of the gas pipe owner. Different areas have different regulations on this, but yes, pipelines directly have been installed in the past.
Okay, thank you.
Tom, we've actually done this in the UK with big contractors here, and I won't tell you their names, but we've worked with large contractors here, pipeline overland contractors, where we've installed the end product pipe for gas installation. So what we normally do as well, we would make up a dummy or a sacrificial pup, steel pup, behind the actual product pipe that we're going to ram. So when we ram each length in, we would cut off the steel pipe and use that pup, which is permanently connected to the rammer. So we're always ramming on that same end piece of steel casing, rather than welding always continually onto the string of pipe that we're installing ahead of us.
Great, yeah, that clarifies it nicely, thank you. Yep. Question from Darren Dickinson. Has compression fit ever been utilized with the casings?
Yes. Bjorn, do you know more about this? I mean, we have used press steel installations where they've got almost a press fit joint together. I haven't personally done it here in the UK, but I think, Bjorn, perhaps you know about these steel casings.
What is that exactly? I didn't understand the question itself. What is that?
Could you repeat the question again, Tom? Sorry.
The question is, has compression fit ever been utilized with the casings?
Compression fit.
And I have to say, I can't elaborate on what the questioner means by compression fit.
Yeah, exactly. This is also my my issue at the moment.
Yeah, if these are preformed joints that they're simply locked together like a snap lock plastic pipe, for example, yes, we have done pre-pressed pipes before, and providing the pipe thickness is sufficient, then yes, we can do this. If I'm thinking right what the questioner is asking.
The only other interpretation I can think of is whether we're referring to, yes, I'm right. Darren has just made a comment. Roger covered it with swage lining. So that clearly that was the thinking behind the question.
Yeah.
Or a swage line, a close fixed pipe like that inside it. So yeah, you did cover it. Thank you, Darren, for clarifying that. And I think we probably covered that.
Darren,
yeah. Thank you. Thinking of preparation, Roger, you stressed the need for good preparation, particularly around alignment and all of those things. But equally, part of preparation is site investigation. You also stressed limitations in terms of soil type, boulders, cobbles, and rock, obviously. If there's a change in soil type on the way through an installation, it suddenly goes from granular to clay or whatever, are you able to deal with that? And also, perhaps what are the key factors in a site investigation up front that enable you to decide on the feasibility?
Well, Tom, thanks for that question. That's often been asked before. That's one of the beauties, I think, of Grundo ram or pipe ramming, in as much as that pipe ramming lends to unfavorable ground conditions. That's why people employ it. You know, where you've got a nice cohesive clay and you know pretty much that it's pretty form right the way across your board, that's fine. But sometimes we don't always know the conditions. We might know it at the start and we might know it at the end. So sometimes people take that in consideration when they want to think about a pipe ram, because if they know that the ground conditions, because of its knowledge, down the road it's changeable and down the road to the left it's changeable a mile, then they're going to think, yeah, I can do a certain amount of test field trials and verticals, but not really sure. Ramming's a good consideration, because unlike any other method, ramming is suitable because everything is taken in that pipe. There's not much apart from solid rock that Roger alluded to earlier that we can't get through. And to be honest, in all my experiences of years of ramming, you wouldn't know too much whether you've rammed through rock and shale, which it's quite easily capable of doing, and then suddenly go to a nice clay. The only thing you certainly feel the change would be in the speed of progress, whether it speeds up, whether it slows down. But even that would be marginal, because once you've got a steel pipe in the ground 30, 40 meters, and we're looking for an 80-meter distance ram on a job, for example, that speed wouldn't vary too much, because skin friction, outer skin friction, would ultimately dictate the speed of that operation. So a change in ground wouldn't be too noticeable. The only thing I would think about before I tackle any job is the ground water retentive, you know, because that can have an influence on the job, and whether the pipes would sink over its own weight over a given distance. And that would be my only thing that I would be concerned about, is whether the ground's wet or whether the ground's dry. But changeable conditions, no. I mean, to give you an example again, I've rammed through railway embankments 40, 50, 60 meters, where I've rammed through solid, very hard, good condition railway sleepers that have been buried in the ground. We don't even know we've rammed through them. It just gets swallowed up in that pipe. And then when you blow the soil out under compressed air, under an evacuation process, only then when you see all the spoil laid out can you see what you've actually rammed through, and you think, my God, I've rammed through that, I didn't even know it. And that's the advantage where you've got unfavorable, unstable ground conditions. ramming has big benefits, big advantages. I hope that's answered it, Tom.
Yeah, thank you. You also sort of anticipated my next question, which is around groundwater. From the way we see the site set up, obviously you're in a pit down at the level of the installation itself. How do you deal with groundwater? I mean, presumably if it's a granular soil and there's a lot of water, you're going to be in a pit full of water, so that's not feasible.
Yeah, Bjorn, do you want to answer that one, or do you want me to carry on? No, I'll carry on, Tom. Yes, we've rammed in quite ground conditions where it's been quite wet. We can't ram in very sloppy ground conditions, because obviously the pipe would literally sink over its own weight as the pipe is moving forward. But we do have little tricks that we can employ, and we can design around the front ram shoe that Roger touched upon again, where we can where we wouldn't perhaps put a cutting shoe around the whole circumference of the steel pipe at the front, would only put it on the top half and not create that overbreak so much, and keeping the pipe as stable as we possibly can whilst going forward. So there are little things we can do to try and keep that pipe level whilst we're ramming. But yeah, we've got to look at that individual project and see how much water is in that pipe before we take a judgment on whether it's acceptable for pipe ramming, Tom.
And Tom, I think I've said it many a times. I certainly have over the years. We don't proclaim that this is the universal solution to every single situation that you might be faced with. But if you seek our advice, one thing that you can be sure about is that if something is not possible, then we will tell you. If we think it can't be done, then we'll have the honesty to say that. We always say we are not in the business of proving that it can't be done, and that promise we extend to our customers. We don't want anybody to set up anyone to fail with our processes.
But Tom, I would add to that, Tom, and everybody's listening. And I'm just going back to the Saudi Arabia project. That was never done before. And whilst we'd say it can't be done, we'll give it a go, providing it's risk-free and there's nothing else to lose except a lost bore, as was the case in Saudi Arabia, where we said, let's have a go. Because sometimes in life, you've got to have a go, because you've got nothing to lose but all to win. And that was a situation going back a few years now, Tom, where that contractor really needed some help. And we at Tracto were very much on board with the contractor and the situation he had led himself into, which was uncalculated, unknown. So we took the risk to fly that machine out there and try and ram back that 42-inch reamer back into the bore to try and free it. And we managed to push that reamer back 5 meters over a 3-kilometer distance back into that bore. That shows you the impact power performance of our very big ramming machines. And I have to say, from a personal level, that taught me a lot of experience about ramming on that one project alone. I was there for 2 weeks there on that project, and my God, was I biting my fingernails. But when that job was done, it was James Bond came to the rescue, and we were held in high esteem. And that project went worldwide. It went viral, and it really put pipe ramming on the map for not just ramming new casings, but for other HD applications, which again, Roger presented very well on his presentation. So sometimes we'll have a go, but we'll try and minimize the risks as much as possible. But there isn't much that we won't say no to. But yeah, we have to consider all the options and all the facts first, of course.
Yeah, I think about the situation in Saudi Arabia, it's very impressive. But as you say, you couldn't really have made things any worse than they were already.
Absolutely. When we say that contractor,
in that situation, you'll have a go. I have just one last question, and Roger, again, in the presentation, you touched on cover and relatively shallow depth installations. Is there a rule of thumb for a minimum cover depending on different soils or so many diameters of the?
Not really. It's not like it is. It is not like it is with the soil displacement hammers, where we need a minimum of 10 times the diameter of the machine as cover. We haven't got a rule of thumb as such. You can think about maybe saying, you are displacing to the surface half of half of the ram shoe from sorry, I've lost my words here. You are displacing sort of maybe the wall thickness of your pipe plus a little bit of the thickness of the ram shoe. Compared to the diameter of the pipe, this is very, very little, but it doesn't work in the same way as it does with a soil displacement hammer. Therefore, it is really experience. One thing is for certain: because you lead the spoil into the pipe, that reduces your heave outside even further. But no, unfortunately, we cannot give you a rule of thumb, not for top cover and not for distance to the other utilities. But if you know that there's nothing that could send the pipe sort of offline, you can really minimize the distance, and we have achieved pipe rams with very, very small distance between the rams that were undertaken. There was a particular ram under a famous brewery in Germany where 2 pipes had to be installed very, very close to each other under the main sort of historic brewery building. So sorry, no rule of thumb.
No, that's fine. No need to apologise for that. Well, that exhausts all of the questions. So thank you once again, Roger, and Roger Atherton as well, and Björn for coming in on the questions. Perhaps, Roger, if you can advance the slide one for me, I'll close the session. So thanks also to everybody who's attended, and I hope you found that educational, interesting, and perhaps has opened up some ideas in your minds. We at UKSTT have a series of online events like this. We have webinars, which are essentially where our members can present their technologies and capabilities and applications to you. We have trenchless tea breaks. As you see on the screen now, there's one coming up 2 weeks today. Trenchless tea breaks are usually a discussion on a particular point of interest with 1 or 2 speakers and a moderator. This particular one is on the revised sewer rehabilitation manual design method for sewer rehabilitation. WRC have recently revised the whole design basis for the sewer renovation manual, and Peter Henley from WRC will introduce that. We also have mini masterclasses such as you've attended today, which are more educational, more technically orientated. I will thank Roger and Björn again for having provided us with such an informative session today. Please look at our website to see all the upcoming events, www.ukstt.org.uk. I will draw your attention also to live events which we have coming up. We're starting again on the 14th to 16th of September. We have No Dig Live in Peterborough, along with our annual awards dinner on the 15th. And then on the 7th of October, a road show in Glasgow. It's a one-day road show, exhibition and some conference papers. And then on the 2nd of November, a full masterclass, a one-day masterclass on large diameter and non-circular pipe rehabilitation. But to say, if you look at the website, you'll see all the events there with information on how to register or how to get more information. So with that, thank you all again for attending. Thank you to Roger, and to Björn. Thank you, everybody, and goodbye.
Thank you very much for your time. Thank you.
Thank you, everyone. Thank you. Thank you.
Bye. Bye. Bye.